Hello, good morning, students. So today we'll continue from the same chapter, input output streams in C++. So we are reaching the end of this chapter also, and in the last video I discussed about the compiler and linker. So if you remember that we saw this diagram. Okay, I discussed about this diagram. So the the code C++ program that you write, it is called as a source code or source file, right? And then you have the preprocessor, uh, and then you have the header file. So the header file is another file. Okay, so another file which contains the stream stream header files. Okay, so you have the IO stream, you have the met.h, you have different types of header files here. Okay, so then the preprocessor, okay, it takes so it tells uh, the compiler tells the preprocessor to include the header files, okay, in the C++ program. So now the source code gets when you compile it, the source code gets compiled into object file. Okay, object file. So a .obj file with the same file name is created. So you have the same Xerox copy of that human readable program in a machine language. Okay, then after that, once it's compiled successfully and there's no errors are found, okay, so when you run it, the linker software creates an exe file. Okay, and then that file you are able to see it on the monitor screen and get the desired output. Okay, so just go through these paragraphs. Okay, so today we'll be discussing about the errors. Okay, so so now, errors can be discovered by the compiler or by linking, or they can appear at runtime. Okay, so different types of errors today we'll discuss. Now, keep in mind that errors in such that these types of errors are like in terms of the errors that are found in the program while you are typing the C++ program. Okay, so these errors are not generated by the computer actually, but these are errors that are made by the programmers. Okay, maybe some sort of like typing mistakes or the logic is not correct. Okay, so these are the errors are generated by humans. Okay, now computer will not make mistakes, but maybe in terms it will make mistakes in terms of like if there's a hardware failure. Okay, but in terms of errors, these are human born errors. Okay, so you have different types of errors based on that. Okay, so you have compiler errors. So this compiler errors is classified into two types, that is syntax errors and semantic errors. Okay, so this syntax errors and semantic errors are further classified in different types. Okay, so some of the errors may be highlighted in the program, in the source window itself. Okay. Now some errors may not be highlighted at all. So if you can see here, this highlighted part, okay, so this is the error. Now of course it will not tell what is the error in some cases, but the highlighted ones, it will be under red margins. Okay, now so semantic errors are like, okay, so the syntax errors happens when you do the after you do the compilation. So if you saw that one, okay, after you write down this source program, okay, source code, and then you do click on file and then you save this program as like .cpp extension. Okay, suppose like uh, test.cpp. Okay, or in this case no name 00.cpp. So this no name is the file name, .cpp is the extension of that. Okay, after that what you do is that you press compile. So when you compile it, it goes through the source file. Okay, it translates into machine language. Okay, and then finds for errors, if there's any error, different types of errors that are there. Okay, so some errors may be bypassed during the compilation time. Okay, there are some errors that will not be found when you do compilation. So that means that compilation will be successful. Okay, but it may be that you will not get the correct output even though the compilation was successful. Okay, so that is detected during the runtime. Okay, when you place on run, and then when you during runtime, okay, that error will be generated. Okay, so you have another one is, suppose like here, semantic errors occurs when the statements are meaningless. Okay, so in this case, this is a statement. So a plus b equal to c, this will be ended by a semicolon. Okay, so when it ends with a semicolon, that becomes a single line statement. Now in mathematical equation, okay, a plus b equal to c, this is correct. Okay, but this means that, okay, you when you add the value of a and b, suppose a is 5 and b is 5, or a is 5 and b is 4, so 5 plus 4, okay, 9, so 9 is stored in c. Okay, but here, okay, but in C++, okay, this equation is wrong. Okay, because in mostly in terms of equation, okay, in terms of the program logic, okay, the evaluation in the execution of the program logic is done from right to left in C++. Okay, so it will be actually not a plus b equals c, it will be c equals to a plus b semicolon. Okay, so it should be written as c equals to a plus b semicolon. Okay, so what will happen is that a and b, a plus b will be 5 plus 4 will be added 9. Okay, and then because of this equal to assignment operator, okay, then from there, whatever value you get a plus b, using this assignment operator, it will be forwarded to the leftmost variable, that is c, so that will be stored in that variable c. So keep in mind that a, b and c are three variables. Okay, all these three are three variables. You are using the arithmetic operator plus symbol, okay, and then you are using this assignment operator. We'll see in the later chapters. Okay, so so keep in mind that it will be c equals to a plus b. Okay, so a plus b value after addition, it will be assigned using the equal to symbol, okay, to the variable c, so that value will be stored in variable c. Now keep in mind that a variable can store only one data at a time, so a can store only one value 5, b can store only one value 4. Okay, so it is not possible that 5 plus 4 equals to 9. 9 can be stored in a, no. 9 cannot be stored in b also, no. It has to be stored in a new variable c, because a is already filled up with the number 5, and b is already filled up with the number 4. Okay, so now you need a new variable to store the value of to store the new value, that is 5 plus 4, 9. So that's why c variable is created. Okay, so when you have sum of two numbers, okay, you need a third variable to store the output value. Okay, and that output value will be displayed by the cout statement. Okay, so now next we have is the linker errors. Now linker errors, mostly it is not highlighted, as you can see in this case. Okay, so the errors are not highlighted. Now here you can see linker error is that here the main, int main, now main is misspelled as MIAN, it should be MAIN. Now main is like a keyword. Okay, so main, when the compiler sees the word main and this parenthesis, this curve bracket, the, the compiler knows that this is a function, this is the main function, and the program execution, the program will start from execution will start from here. The program will execute this function body within this opening curly braces, and then the program will terminate by the main function. Okay, but when the compiler sees that the name MIAN, it is misspelled, compiler will not recognize what this word is. Okay, so it shows the error in a new window. Below this, another window will be created. Okay, so it will show undefined symbol MIAN. Okay, so this error will be displayed. Okay, undefined symbol. Okay, in, so this is linker error. Okay, so linker error, as in the sense that, keep in mind the linker, it will create an exe file, right? So since the main program execution is not spelled out correctly, okay, so what will happen is that the linker error will not be able to create an exe file, and hence you will not be able to run the program until and unless you correct the error. So keep in mind that in a C++ text editor, it can display the error, and it is also possible for you to correct the errors. It gives you a chance to, the text editor gives you a chance to correct the errors and then redo the program. Okay, so that is why it is called as an IDE, okay, integrated development environment. Okay, in some cases it is also called as RAD. Okay, but in RAD, rapid application development, you can create softwares, okay, uh, that has GUI, graphical user interface forms also. Okay, now syntax errors. So we come to the syntax error. Syntax error is the most common errors that you will find. Okay, so syntax errors is like created by humans. Okay, and it is like errors just like this linger error, MIAN. Okay, so syntax errors are when we violate the grammatical rules of the programming language. Okay, so uh, we have to follow a certain protocol while we write down the C++ program. Okay, so some certain rules has to be followed. Now when we violate that rules, okay, and we misspell it, we do not follow the rules, then syntax errors are created. Now this is the easiest errors to be found because the errors are highlighted. Okay, so most common error are much easier to correct than other errors because they usually produce a helpful error message. Okay, so the errors will be highlighted, the errors will be displayed. Okay, so like example in this case, if you see here in this example, okay, so hashtag include within the angular bracket studio.h, hashtag include uh, cinio.h. Okay, so these two are your header files. Okay, this is your standard input output header file, this is your ci. So you can see that cinio, so this is misspelled, it should be conio, console input output. Okay, so this is one type of error. Okay, now if suppose you forgot to mention this, write down this hashtag. Okay, or you misspelled, instead of include you wrote suppose like uh, instead of writing inclute, okay, you wrote imclude, so that is also misspelled, right? N is misspelled to M, so that is also a grammatical mistake. And maybe is you forgot to close the angular bracket. Okay, or suppose like you might have written int x equals to 0. Okay, or you might have not include the semicolon because every line terminated by a semicolon, right? So that is also another grammatical mistake or syntax error. And here also see whi, it should be while, okay, but l is missing, so that is another syntax error. Okay, so lots of errors like that will be found. If suppose this one, you have the opening bracket, you have the closing braces. Now if suppose this closing bracket is missing, that is also another syntax error. So the grammatical, because in C++ program, for every opening bracket there should be a closing bracket. Okay, like this one, for every opening bracket there should be a closing bracket. Okay, so if suppose here C out, maybe you mispronounce it to L out, or suppose you are using the insertion operator here, or this overload operator, and if suppose you reverse this sign and this angular sign, okay, C out and then greater than symbol. Now you know that the greater than symbol is used in C in operators, right? So that is another grammatical errors. Okay, so this type of errors mostly are generated by humans, and these are the errors that are easily detected because they are highlighted. Okay, and they can be easily corrected also. Okay, so later on in your systems you can type these programs, okay, and change these programs and then find out what different types of errors you're getting. Okay, and then you'll know more about those errors. Okay, it is very important that you know these different types of errors so that you can because keep in mind that when you type the program you're sure to get errors. Okay, so it is never 100% that you sure that you will not make mistakes while typing the programs. Okay, so that's why it is much essential that you know different types of errors. Okay, now runtime errors. Now like I said, runtime errors are during the program compilation time. You may not find any errors at all. Okay, so here when the program is compiled and it does not produce any error, it does not mean that it will produce correct results. Okay, so like I said that sometimes you may compile your program successfully. Okay, but uh, however, it may not be that even if the program is compiled successfully, you may get the correct result. Okay, it will happen after compilation when you press run. Okay, so when you click on the run, then what will happen is that a runtime error will be generated. Runtime error is mostly generated during when you are trying to get the output. Okay, it may be that you may have entered the input data incorrectly. Okay, if you see in this particular example, suppose like here x equals to within the parentheses, okay, a plus b divided by c. Okay, so this is a formula to be executed. Okay, so as you can see here, this is a correct way of assigning, because like this will be evaluated. Okay, it will be divided by c. After that, that value will be assigned using this assignment operator equal to sign. It will be assigned or stored in this variable x. It cannot be a plus b divided by c equals to x. So this is the proper way, okay, from right to left. Okay, now just like later on you will see that just like this in maths, BODMAS rules, right? So in C++ programs also, there is precedency of order in like the symbols, okay, like bracket, plus symbol, division symbol, multiplication symbol, equal to symbols. Okay, so higher priorities are given to different symbols, okay, to arithmetic operators, relational operators like the greater than, less than. Okay, so that you will see in the later chapters, next chapters. Okay, so here the program logic, it looks correct. Okay, but when you run this program, okay, after you compile it, okay, when you run this program, if suppose here it is said here, if you divide this equation by 0, so what will happen is that if you try to divide it by 0, okay, you will get an illegal program termination, okay, because it is not divisible by 0, right? So it is not divisible by 0. So in that case, what will happen is that you will get different options which will force you to shut the program. Okay, so in such cases, okay, if that kind of runtime errors are generated, okay, then uh, is here. A programmer can protect the program from runtime error by including in its code all the possible cases that the user want to do in case an execution error occurs. Okay, so the programmer should be able to catch those type of errors. Okay, we should be able to predict and catch those type of errors and write down code such that it will detect those errors, okay, and then find a possible solution for that. Okay, what I'm saying is that in real life programming situation, okay, in real life programming situation, so it should be able to do that. Okay, so here to terminate the program, okay, so the program should abruptly terminate, okay, to input correct data and continue. Okay, so what if you get the chance to again enter the correct data, okay, and then execute the formula. Okay, so suppose instead of 0 you get the chance to again enter the number, suppose like 1 2 like that, then in that case it becomes divisible. Okay, or to continue with the writing data, okay, simply continue, but it is, of course, it is not applicable. Okay, and then to continue program by ignoring the faulty data. Okay, so these things are not applicable in case. Okay, so runtime errors, okay, during compilation time it will not produce any errors, but when you actually run the program or try to run the program logic, okay, then in that case it will show the errors. Okay, so this is called as runtime errors. Now logical errors, okay, logical or errors, it happens when you compile it, you will get these types of logical errors. Okay, so logical errors are like in case uh, here in this example you can see that, okay, you have a quadratic question formula. Okay, so what happened is that what is applicable in maths, you can, maybe you can write down in this way. Okay, but in C++ program, okay, you have to split the formula logic into different parts, because it cannot execute all of this formula logic at one go in C++ program. Okay, so how you execute in the maths formula and how you execute that maths formula in C++ is different. Okay, so the program logic should differ. Okay, so here a logical error is simply an incorrect translation of either the problem statement or the algorithm. Okay, what is algorithm? I'll come to that later on. Okay, so an excellent example of the logical error is finding the root of quadratic equation. Okay, so this is the formula. So if you write the above statement, it is synthetically correct and not produce any error. But if you compile the program using above statement, okay, so that's what, when you compile the program and when you try to run it, it will never give correct output. Okay, how you get the output in maths and how you get the output in C++, if you use the same program logic, okay, you will not get the correct output. Okay, because here, because we know that the division has a higher priority than the addition. So in the above statement, division is performed first, then addition is performed. But in actual practice, we have to do addition, perform, then divide the resultant value by 2 into a. Okay, so like I said, okay, the way of execution is different. Okay, so we have to split up this formula into different parts. Okay, so that you will get the correct output. Okay, so when the logic, so these formula parts, these are called as the logic section. Okay, so when the logic in the C++ program, okay, uh, it becomes meaningless. Okay, so in that case, or incorrect way of representing, okay, the formula, then in that case you get this type of logical errors. Okay, so these are the different types of errors that you'll see in your C++ programs. Okay, as you type those programs, so in your textbook, if you have the textbook, okay, you can see different types of programs. Okay, so try those programs. Okay, go through these chapters. Okay, later on I'll give you the printout of this whole chapters. Okay, so for today I'll stop on there, and from tomorrow I'll discuss some from the solve exercises. Okay, so uh, just go through the textbook and try to understand every topic.